All right, we're going to be talking about polygons today and their angles. Does anybody remember what a polygon is?
It has 6 sides, or 8, or 7.
It could have 6, it could have 8, it could have 7.
One that has more than 3 sides.
Oh,
It's not. It doesn't. It could have 3 sides. This is a polygon.
Any shape.
What can it not have? It's a polygon.
2.
It can't have 2. That's for sure. Because 2. What if it had 4?
Can't have 4.
That's got 1, 2, 3, 4.
It has to be closed.
Has to be closed. That's right. It has to be closed. What else can it not have? I actually didn't draw this one well.
Curves.
It can't have curves. So if I had like this, and then that is not a polygon. Okay. So a polygon can be a triangle, square, hexagon, heptagon, all those things. Today we're going to talk about its angles and what they add up to, how to find what they add up to, or interior ones, exterior ones, and so forth. Okay. You have a note sheet if you'll get that out. We're going to be finding a formula. You have already copied this table because I've given you a copy of it. And so I have filled in the first one. If we have a triangle, and I'm going to try to draw a triangle up here. If we have a triangle, this has how many sides? 3 sides. That's why there's a 3 right there. How many triangles are there? And this is kind of a weird question. How many triangles are there? Well, there's only one. And when we get to the later ones, you'll understand what I'm talking about. This one kind of seems strange to ask the question, how many triangles, when I only draw one triangle? It seems obvious that there's only one. What is the sum of the measure of the interior angles for that? 180. You memorized that one. So now I'm going to bring up.
Yes.
There's the triangle that I brought up. It's got 3 sides, 1 triangle, and 180. Now I'm going to bring up a quadrilateral. And I did not bring up some square or a rectangle. I brought up some, not even a trapezoid. It's just some quadrilateral. How many sides does it have?
4.
4 sides. All right? And I've already drawn the 4, but you can't see it because my font is really low right there. Now, I just connected and put a diagonal in there. How many triangles is that right
2.
now? So if I asked you what the angle measures were for this and the angle measures for this, it would be 2 times 180, correct?
Mm-hmm.
Which is 360,
360.
right? So let's do that. Hopefully it'll bring up the nicer numbers. And you see that too?
Yeah. A
Right.
little. Yeah.
A little bit. My
Yeah, I
font's
can see
really
it.
off.
Do we
And
have
then-
to write 2 times 180?
You need, yes, because what we're going to try to do is, what if I had a 75 gon? What would they all add up to? What if I had not a hexagon, but an octagon? And I don't want you to have to count, and I don't want you to have to draw the picture and figure out how many triangles there are. I want you to just know what the formula is. So right now, a quadrilateral has 4 sides. That means there's 2 triangles. That means it's 2 times 180. Let's bring another picture up. This is a 5-sided. This is a pentagon. And I'm going to draw 3 of them. So I just drew 2 diagonals, which are 3 of them. So it's going to be 3 times 100. Does anybody have any predictions on how we're going to just jump to know that it's 3 times 180? Is there a relationship right now that anybody can figure
Go
out?
up?
Pardon me?
Does it just go up 1 by 1?
Okay, so it went up to 1 to 2 to 3, and this went 3, 4 to 5. But what if it's a 12? If this is 12, how much will this be over here? Yeah, so if I had or even a
10.
a 10 here. Okay, 12. Wait, a 10 here. This would be a what over here?
8.
How do you know?
Minus 2.
You sure? Are they always minus 2? Is this minus 2?
Yes.
Is that minus 2?
Yes.
So these right here are down by 2 every time?
What did y'all get for the degree? For how many degrees it is?
It says 540 up there.
Okay,
Sorry.
okay.
Yeah. Okay. So if we do a hexagon and we bring a hexagon up there, let's clear the screen. This is going to be a 6, right?
Mm-hmm.
This is going to be a 6. What's this going to be? If you predicted right.
4.
We think it might be a 4. And so this will be 4 times 180, right? Whatever that is on your calculator. So let's do it. Let's look at the picture and see if we predicted correctly.
720.
We predicted for the hexagon already. And it was. So if I brought a hexagon up, I'm going to just bring one up.
Wait.
So I got 1, 2, 3, 4, 5, 6. I can draw one there, one there, and one there. So I have 1, 2, 3, 4. Yes, it is going to be 2 less than the number of sides. So
Wait, is the last one, is that a nonagon or what is just n dash
now
one?
this is what I want us to be n. What any side? So if I have any side, what am I going to do to n to get this right here?
N minus 2.
N minus 2.
Okay.
So
Got it. That makes sense now. Got it.
N minus
so
2
this is
times
going to be
180.
n minus 2 times 180. That is where that formula that you wrote in your Formula Madness comes from. So that when you're writing it down, maybe doing this whole process will help remember it as you're going along. It's always, the number of triangles is going to be 2 less than the number of sides, always. So let's do, you just watch this next thing. What are the, oh wait, actually, now I have, what kind of shape is this one?
Pentagon?
A pentagon, and I have, these are all exterior angles. I have this, these are all the exterior angles. What do you think the sum of all of them are going to add up to be?
360.
It's 360. No matter when we rewrote that in your Formula Madness, no matter what, if it's a 6-sided figure, a hexagon, a pentagon, a heptagon, a nonagon, a dodecagon, they're all going to be 360. So the question comes up here. The question, what is the measure of the exterior angles? If this is regular, this is a... Now, how did we get 72 for this? If all of them are 360, that's why. What is the measure of all of, if this is 360 for, they add up to
Measure of
360,
one?
measure of one of them, and that's why it has to be regular for us to do that. So what did I do to get to 72?
Divided by
Yes. I should have read that. What number do I put down here for this one?
5.
Yes. I should have read the question. What is the measure of each extra angle of this one? It's 5 because I divide by how many there are, which is 72. Okay. All of it's 360, but if I want each one, I need to divide by the number of angles that there are. All right, we're going to do numbers 1 through 17 odd on your homework, so go ahead and get those out. All right, here's number 1. It says, state if each polygon is regular or not. This is review from a long time ago. What does it mean to be regular? What does it mean to be regular?
Have a shape or
It has to do with how it's shaped.
Is it that all the sides are the same length?
Yes, all sides are equal. So that means that it would be like an equilateral triangle would be a regular triangle. Is this regular? How do you know?
Because, well, it's definitely deformed.
Okay. Yeah, it is. And so usually, and when you see it regular, it looks very attractive to us usually. And this one looks deformed. But can you notice that some of them are longer than the others?
Yes.
Like this one down here is definitely
Much
longer
longer
than
than
that
that
one,
one,
right? So
yeah.
it's not regular. You are correct. Number 3, find the interior angle sum of each polygon, round to the nearest tenth if necessary. Okay, so what is the number of sides for this one?
6.
All right, so what formula do I put this into?
6 minus 2 times
6
180.
minus 2 times 180. I don't know why we'd need to have any rounding, but what is 4 times 180?
720.
720. Someone verify that.
Verified.
Okay, good. Do number 5. Well, how many sides are there on this one, Amy?
I was going to do 3. Well, 5.
Good.
It would be 3.
So it's 5 minus 2 times 180. Now I'm going to ask most of you if you'll please plug it into the formula for me. You can do the 3 part if you want, but you don't have to. You can just now put into your calculator 3 times 180. You don't have to write that step if you don't want to.
I don't
What
want
is-
to, but Dad makes me do it.
If
so
your
I
dad
keep
makes you do it, you
yeah.
do it. That's right.
Yeah.
So what is 3 times 180? Someone help me.
No,
540.
Is that what you got?
540.
Fantastic.
How is the instructions for 7 different from
Just a second, I'll get there. Let's do number 7. It says, find the measure of one interior angle in each regular polygon, and it tells you how to round if you need to. So, first of all, we need to know the sum of all of these. This is n minus 2 times 180. What is n in this case?
4.
4 minus 2 times 180. You really don't have to. I'll tell you why in a moment, but if you wanted to do the formula, I think you're going to be very...
Square.
So it is a square, but we're going to do the formula anyway. So that means it's 2 times 180, which is 360, correct?
Yes, ma'am.
How am I going to find just 1? I have the sum of that.
Divided that by 4.
How did you decide 4?
Number of sides.
Number of sides. What is 360 divided by
90.
4? 90. Now, if you have a regular 4-sided figure, it is automatically a square. And so you probably could have just written 90, but I wanted to go through the process so that when you get down to the other ones, you also can do them. Are there any questions on number 7?
No. No.
Let's move on to number 9. This one has the same instructions. Find the measure of one of the interior angles of the regular polygon. This has how many sides?
5, 6.
So it's 5 minus 2 times 180. That makes 3 times 180. Can someone tell me what 3 times 180 is? 540. But we're not finished here. We need to now divide this by what?
5.
Yes. All right, number 11 says find one exterior. Make sure you're reading the instructions. Exterior angle. How much is all the exterior angles add up to be? How much?
360.
360. How many sides is this? 1,
10.
2, 3,
10.
4, 5, 6, 7, 8, 9, 10. Okay, so we're going to divide this by
10.
10. And 36 divided by 10. 360 divided by 10 is
36.
36. We keep saying the answer over and over. All right. So on these, it's actually a little easier because 360 is going to happen over and over. Let's move to number 13. All right. This one is a little simplistic, I think. You might know the answer to this one without doing any work. If you understand what exterior angles are, the exterior angle is just going to be, if this one's 90, then this one has to be what?
90.
90. To show if you needed to show work, if like a father was making you show your work, which is fantastic, you take your 360 and you divide it by 4 and you would get 90 degrees.
So that I can't hear my brother talking.
We're going to do some more review of algebra. You will need this. We're going to do some systems of equations. We're going to start out with some basic ones this week, and then I'll move to them getting a little more complicated, all right? So if this is in any way something you don't understand, please stop me and ask me. We're going to do this with a method called elimination, all right? Elimination means we're going to eliminate or cut something out. When we do that, we're going to add, and something should fall out. Our goal is to find an x value and a y value in ordered pair like on a graph. So we will need two numbers, an x and a y. When we're using the elimination method, we put a line underneath and we add. These y's, this is the part that elimination is wonderful. What is negative y and positive y? What happens to those?
0.
They cancel out, and that's what we want. That's why we're doing the elimination method. This week's every single one of them will just cancel automatically. I will show you what happens when they don't cancel next week. All right? We're going to add those up. This is 8x plus 2x is
10.
10x.
bring down my equal. 1 and negative 11 add up to be
Negative 10.
negative 10.
Okay, question though.
Yes.
If you did bring like a number down from where the y's were, like if you just brought that 0 down, what would you like put to separate the two numbers? Does that make sense?
Plus or minus in this case because it wouldn't matter but you wouldn't want to because right now you know that 10x equals negative 10. We can divide by the 10 like we've been doing with before. And x is going to be what?
Oh, wait.
Negative 1.
Yeah.
All right? We are not quite finished. Over here I told you, remember, we're having an x and a y. I know my x value is negative 1, but I need a y value.
0? Because they cancel out.
It's not 0 because we have to plug it back into one of these equations here. You get to choose in this world where all the adults are telling you what you can and cannot do, I am giving you a choice. Do you want the top one or the bottom one? And it won't matter which one you choose.
Well, the bottom one you're adding. But it's
Okay, you like the bottom one because you're adding. So you're choosing the 2x plus y equals negative 11. All right, so I'm going to plug in that negative 1 in for x right there. So we'll have 2 times negative 1 is negative 2 plus y equals negative 11.
Wait.
I plugged in, Amy.
I see what you did, but I was wondering why the x was... Oh, never mind. Okay.
I'm going to add the 2 to the other side, and y will equal negative 9. That is the y value that you needed. If you were to plug this ordered pair in for these two equations, they would work.
There is no x, so that you have to find the y.
Yes.
I
All
did
right.
the same thing.
Yeah, okay.
Your elimination this week will automatically, either your x or your y will eliminate automatically. You won't have to do any special things. Next week, we're going to be adding more to this. Okay?
Yay. Hey, somebody had...
Let's do number 17. This is another method. This is called substitution. I had somebody ask me about this one a moment ago. Notice that both of these equations are not done yet. Could be. And so,
I have a question about it.
okay, you'll get there in a minute. So, I want you to notice that this one right up here is written in what we call standard form. And this one down below is written in slope-intercept form. This one says, the bottom one that we have down here says that y equals negative 2x minus 13. I am going to rewrite, just for simplicity up here, or just so I can see everything.
I think I know this.
This says, over here, this says here that y equals negative 2x minus 13. So in the place of y in this equation, I can substitute in a negative 2x minus 13. I'm going to say that again. This equation here says that y equals negative 2x minus 13. So in the other equation, in the place of this y right here, I can substitute in a negative 2x minus 13. So this is what I'm going to write. Negative 3x plus 6. And instead of the y,
I'm going to open parentheses negative.
I'm going to put in the negative 2x minus 13. Yes. Then I'm going to solve it like an equation that I've done in the past. I'm going to distribute the 6 to everything in that parentheses there. So I'll have negative 12x. Oh, what is 13 times 6?
90. No,
78.
Sorry.
And it's a negative 78.
Yeah, never mind.
Those come together to be negative 15x minus 78 equals 12. I'm going to bring the 78 over.
Oh, wait, that's...
And I will get 90. Then I'm going to divide by the negative 15. And x is going to equal negative 6, I heard. Now, am I finished?
No.
Be careful. When you're doing these and you get x equals, you circle your answer and you're done and you go to the next one. In these cases, you're not. You have half the answer here. The second half is not too hard, though, and I want to make it even easier because you can plug it into either one of these equations, but I'm going to tell you the easiest of them.
It's the y where
It's the y equals one that's already solved for because you don't have to divide for it by anything. We're going to plug in our negative 6 for that. Y equals negative 2 times negative 6 minus 13. Y equals 12 minus 13, and y equals what?
Negative 1.
That's correct. Negative 6, negative 1. This is the point that if I plugged it into both of those equations, it would be true. It has, and also happens to be if you graph those two, they would be lines, and it would be where the lines cross. You're going to need this stuff for when you do some some of your geometry. And so we're reviewing this and going to get you to be able to do this well before we jump on to that part. Okay? All right, this is what we learned. You have some formulas for this week. You have a formula for the sum of the interior angles of a polygon. You also know that what the sum of the exterior angles is. It's just 360. I hope this has been helpful. Goodbye.
Wait a minute.